Okay, let's dive right into this explainer. Today, we are confronting a fascinating illusion, one that's sitting right inside your own head. We're going to decode exactly how people think, tracing the nuts and bolts of human cognition from our ancient evolutionary past all the way to some cutting-edge modern neuromapping. So, you probably feel like you know exactly what goes on in your mind, right? We usually experience our consciousness as this neat, orderly monologue where one thought logically leads to the next. But actually, the vast majority of the cognitive machinery determining your everyday decisions, it operates in total silence. A lot of the time, we're literally completely unaware of how we even arrive at our conclusions. Here's the roadmap for where we're going. 1. The evolution of thought. 2. Two systems of thinking. 3. The mechanics of reasoning. 4. A hidden language of thought. And finally, 5. The brain's universal map. Section 1. The evolution of thought. Tracing the origins of our cognitive machinery. So when did we actually learn to think? Well, it goes way back, about 300,000 years ago, with the biological expansion of the prefrontal cortex in early hominids. This physical upgrade to our hardware is what first let us synthesize signals and run complex behavioral programs. And then, fast forward to recorded history, you see humanity really trying to figure out this hardware. We go from Aristotle formalizing deductive logic, to John Locke arguing we're blank slates, learning strictly from experience, all the way to John Piaget mapping out exactly how cognitive reasoning develops in children. Now, what's really wild is that processing information is a universal survival mechanism for literally all life. I mean, even a simple bacteria like pneumococcus can process threats, adapting and entering a dormant state just to evade antibiotics. But here's the difference. While bacteria are basically just reacting, human brains evolved this extraordinary superpower to process abstract logic and consciously manipulate information. Moving on to Section 2, two systems of thinking, the fast and the slow operations of the mind. Okay, the crucial thing to understand here is that we basically rely on a duality when processing info. Pioneered by the famous psychologist Daniel Kahneman, this framework splits our brain's operations into two totally different gears. On one side, we've got System 1. This is rapid, automatic, and highly emotional. It makes snap judgments using mental shortcuts or heuristics. Then we have System 2, which is slow, effortful, and deliberate. It's the one that steps in for complex logical computations. Like you're using System 1 to effortlessly listen to my words right now, but you'd absolutely need System 2 to sit down and solve a calculus problem. Behind the scenes, System 1 generates this feeling we call cognitive ease. Basically, when you have repeated experiences or an idea is kind of primed in your environment, your brain processes it super smoothly. This ease makes the information feel familiar, effortless, and most dangerously, it makes it feel true. System 1 literally creates an illusion of truth without us even realizing it's happening. You can think of System 1 as a sort of mental shotgun. Whenever you're awake, it's continuously reading the cockpit dials of your environment. You know, like, is there a threat? Are things normal? Do I need to shift my focus? It does all this completely automatically. It only sounds the alarm and recruits the slow, deliberate System 2 when it hits a novelty or some complex problem it can't just substitute with a simple shortcut. Up next, Section 3, the mechanics of reasoning, from raw sensory input to abstract thought. So how does the thought process actually work? Well, this is the step-by-step pipeline of human cognition, transforming this chaotic swirl of sensory stimuli into a coherent experience. First up is perception, taking in physical light and sound. Then attention kicks in, like a filter, putting out the irrelevant noise. Next, memory stores and retrieves these chunks of data. And finally, we hit thinking. That's the stage where our higher-order reasoning faculties actually take those concepts and manipulate them to solve problems and make decisions. Now, for centuries, brilliant minds just assumed this final stage of thinking was permanently glued to language. Back in 1854, the mathematician George Boole wrote that it was a truth generally admitted that language was the actual instrument of human reason. And this idea sparked a massive assumption in cognitive science known as the language of thought hypothesis. Basically, the idea that our internal native language is the underlying code our brains use to compute logic. Which brings us to Section 4, a hidden language of thought, debunking the illusion of the inner voice. Okay, what if I told you that historical assumption is entirely wrong? Seriously, if you look at the functional topography of the brain, the logic network is geographically and functionally completely separate from the language network. So, do we have a hidden language in our brains that allows us to think? Science is increasingly saying absolutely not. This is such a massive revelation. Abstract logical reasoning actually utilizes its own dedicated network in the left frontal cortex, totally distinct from the language center or even social reasoning systems, and we know this for a fact because of patients with profound aphasia. These are people who've suffered brain lesions that completely wiped out their linguistic abilities, yet they can still perform complex logical and mathematical tasks flawlessly. It proves that you don't actually think or reason in English or Spanish or any other natural language. Language is just an expressive interface, guys. It is not the source code of your thoughts. Finally, Section 5, the brain's universal map, how the bilingual brain organizes semantic meaning. So, if our thoughts aren't made of words, how does the brain actually store the meaning of the world around us? Well, recent neuromapping of bilingual patients who were being evaluated for epilepsy gave us a pretty incredible answer. Researchers tracked individual neurons and discovered that the English word earth and the Spanish word tierra light up the exact same universal meaning map in the brain. This means human brains do not build separate translation dictionaries for different languages. Instead, meaning is constructed by the joint work of entire groups of cells in the hippocampus. The brain just uses a singular, universal, three-dimensional map of concepts. English or Spanish simply read from this shared map. And honestly, what's absolutely fascinating here is that this biological neural organization strongly mirrors the hidden layers of how modern artificial intelligence models structure meaning and data. So, we've uncovered that our inner voice is really just an interface, a clever illusion hiding a much deeper, wordless logic network. And that leaves us with a pretty profound question. If our most complex thoughts exist totally independently of the languages we speak, what does this reveal about the inner lives of nonverbal animals? And as we build AI that mirrors our own semantic mapping, what is the true hidden potential of artificial intelligence? Definitely keep those questions in mind next time you catch yourself thinking about, well, how you think.